In this video, we'll discuss how to write and analyze chemical formulas. Chemical formulas represent the elements in a compound. You have the symbols for each element, and then you have subscripts that tell you how many atoms of each element you have. So in this case, we have hydrogen and oxygen, and the 2 only represents the number of hydrogens. So the subscript will follow the element that it represents. When you write the formulas for a compound, you list the elements from left to right in order of lowest to highest electronegativity. The trick to doing that is listing elements from left to right as you see them on the periodic table, and then if they're in the same group, you would arrange them from bottom to top. An exception to this is hydrogen. Hydrogen should be listed last because it's a nonmetal, but its position on the periodic table, it's next to all the metals, so it looks like it would have a lower electronegativity, but it actually has kind of a high electronegativity. So hydrogen should be listed last unless there are elements in group 6 and 7A, then it comes before those. Here's an example. In this compound, bromine, hydrogen, carbon, and iodine are all present. They're all bonded together. And so the trick is to look at the periodic table from left to right and then bottom to top. Remember that hydrogen is an exception. Hydrogen is at the end unless there are group 6 and 7A elements. And if that's the case, then hydrogen comes before these. And that's what we have here. We have hydrogen. We have elements in 6 and 7A. So we're going to ignore hydrogen for now. And we list elements as we see them from left to right. So carbon's the first one we see. So carbon's the first one we write. Hydrogen will be next because it has to be listed before 6 and 7A elements. So we have 2 hydrogens, 1, 2. And then next, we have 2 elements in 7A listed from bottom to top. So iodine and then bromine. So the formula is CH2IBr. Sometimes the formulas are more complex, like this, where you have parentheses. Again, the subscripts represent the number of atoms of that particular element, and it'll be listed after the element. So this 2 represents the number of aluminum, so 2 aluminum atoms. This 4 only represents the number of oxygen atoms, so 4 oxygen atoms, but we have parentheses. When you have parentheses and a subscript after the parentheses, you have to multiply everything inside the parentheses times that subscript. So if we originally had 4 oxygen atoms, now we have 4 times 3. Then also you have sulfur. 1 sulfur times 3. So you have 3 sulfur atoms, and then 4 times 3 oxygen gives you 12 oxygen atoms. So let's look at this example. We have another one of these compounds that has a formula with parentheses. How many oxygen atoms are in this formula? We have 3 oxygens, but there's parentheses. Outside of the parentheses is a subscript of 2, so we multiply everything inside by 2, but remember, we're only focused on oxygen. So 3 oxygen atoms times 2 is a total of 6 oxygen atoms. In this example, SiH3, 3N, how many silicon atoms are there? Well, when you look at it, there's just 1, but we have parentheses. On the outside of the parentheses is a 3, a subscript of 3. So we have to multiply everything inside the parentheses by 3. 1 silicon atom times 3 equals 3 silicon atoms.